Hey, good day to everyone. Today we're going to discuss Module 1, Unit 2 of CE 2221, which is the uniform rectilinear motion. So for any particle moving in uniform rectilinear motion, take note that the acceleration will always be equal to 0 and the velocity will always be constant. So if you could remember from physics, the equation for acceleration is given by E is equal to Vf minus Vi divided by time. And since V is a constant, so Vi is equal to Vf. So in that case, the difference now will be equal to 0, thus making the acceleration equal to 0. So that this is where we have taken the definition for acceleration and velocity for uniform rectilinear motion. So in calculus form, we'll have d of x with respect to d will be our v, and that will always be a constant value. So in that manner, for the position coordinate x, we now compute this as the integral of the equation. So we'll have the integral of dx is equal to v times the integral of dt. So simplifying the equation, our integral equation, will now have x minus x sub o is equal to v sub t. Or we will now have x is equal to x sub o plus vt, which will be our equation 1.1. So if you will now again remember from physics, if x sub o is equal now to 0, then we could simplify our equation simply as x is equal to v times t. So take note, for our equations, x is equal to your final position at time t, and x sub o will be your initial position. Just a review, for particles in uniformly accelerated rectilinear motion, or UARM, we have already discussed this from physics, and you have derived this already using calculus. The acceleration now will always be constant for this type of motion, and the equations that you're going to use for your linear motion of UARM will be given by the equations v is equal to v sub o plus at, x is equal to x sub o plus vo t plus 1 half at squared, and v squared is equal to vo squared plus 2a times x minus x sub o. So from physics, what you use for this equation is simply x, because we have derived it using x equal to 0, or x sub o equal to 0. Okay? So in relation to UARM, we have a special type of motion again, which is your free-falling motion, or any body or particle that would be moving in free fall will have a uniformly accelerated rectilinear motion, but it will now be moving along your y or vertical direction. So in here, the acceleration is always negative since the object is always moving downwards, and an acceleration is a vector quantity. So for your acceleration, we'll now be using the value of g, which is equal to 9.81 meters per second, and g in feet per second squared is 32.2. So these two values should always be negative for your computations. So for the equations of free falling body, it would be the same with this equation. The only difference is that your acceleration becomes g and your displacements become y. So for equations of free falling body, we'll now have v is equal to v sub o times ag or gt. And then we have fy is equal to y sub o plus v sub o t plus 1/2 gt squared. And lastly, we have v squared plus vo squared plus 2g times y minus y sub o. So in physics, for simpler analysis and simpler memorization of the equations, we always assume that y sub o is equal to 0. So, kaya ang naging equation natin dito is only 2gy. And at the same time, here, y sub o is also equal to 0. That's why for your equations, if you could remember from physics, that's y is equal to v sub ot or vit plus 1/2 gt squared. So if you could remember from your physics subjects, what we were only solving there was the motion of a single or one particle or one body. So in dynamics, we now consider two or several particles that will be moving together or will be affecting the motion of each other. So in that case, we now have what we call the relative motion of particles, specifically two particles. So the motion of two particles will always be or will also be defined by its position, velocity, and acceleration. So in that case, the relative position now of two particles will be given by the equation x of b with respect to a is equal to xb minus xa. So in that case, we could also define the position of a with respect to b as equal to xa minus xb. Okay, so here x of b with respect to a is simply defined as the relative position coordinate of b with respect to a, or we observe the position of b when you are at a. So take note, regardless of the positions of a and b with respect to the origin or your reference point, the sign conventions now will follow. So a positive xb with respect to a will simply mean that b is to the right of a. So in that manner, so in any position, whenever b here, when you are at a, the second particle will always be at the right of a. So that will be a positive relative position. And if we have b, which is located to the left of a, then you will have a negative sign convention. So if this is, for example, point A, you are point A, and you are looking at the second object to the left, then their relative position is a negative value. Okay? So, ibig lang sabihin yan, kahit na ang ating, kunwari, ito yung origin natin. This is our point of origin. So, kahit nandito ka sa may left side ng origin, kung yung B is at the right side, it will still be a positive XB with respect to A. Okay? So, kahit na nandito yung origin natin, which is, and your particles are on the positive side or positive direction, as long as B is on the left side of A, your XBA will always be a negative value. Okay? So the next definition for relative motion of two particles will be its relative velocity. So same as for the relative position, the relative velocity of B with respect to A will be taken as VB minus VA, wherein VBA is the relative velocity of particle B with respect to A. So note for our sign conventions that we'll have a positive sign for VB with respect to A if B is observed from point A or from particle A is moving in the positive direction, and a negative sign for the relative velocity of B when B is observed as moving to the negative direction. So to understand the relative velocity of two particles, specifically the sign conventions, let us look at these diagrams. So as you can see, whatever the positions of A and B, as long as B is moving to the right direction or to the positive direction, then it means that the relative velocity of B with respect to A will be a positive value. Likewise, whatever the position again of A and B, as long as B is moving to the negative direction, then, or moving to the left direction, then the relative velocity of B with respect to A is negative. So the next concept that will be defining our relative motion of two particles is their relative acceleration. So again, same as position and velocity, the relative acceleration of B with respect to A is taken as acceleration of B minus acceleration of A. So B with respect to A is the relative acceleration of B. So this is read as this one. So for some particles, their positions would usually be dependent on the position of another particle or sometimes of several other particles. And in this case, this is what we call dependent motion. Okay, so to understand dependent motion, let us look at this figure. So we have here two blocks, which is A and B. So from the figure, the position of block B now would depend on the position of block A. So whenever block A moves, basically it will also affect the position of block B. So in that case, since the rope is of constant length, meaning it follows that the sum of the lengths for each segment, so we have here your segment for A, and this is for B. So it will now be given by 1 degree of freedom. So we'll have XA is equal to 2XB, which is constant since our rope length is also constant. So another example for dependent motion. So let's take into consideration the blocks or figure 2.2. So from the figure, we could see that the positions of the three blocks are dependent from each other. So in this figure, we are now given a 2 degree of freedom, and that will now be defined by the equation 2xa plus 2xb plus xc. And for linearly related positions, this equation now can be related also between our velocities and acceleration. Okay, so with that, we simply get the derivation of the position equation. So for velocity, we now get the 2 dxa with respect to time plus 2 derivative of xb with respect to time plus d of xc with respect to time, and that's equal to 0. So if we simplify that, dx over dt is our velocity. So we'll arrive at 2va plus 2vb plus vc, and that's equal to 0. And at the same time, taking the derivative of our velocity, we'll now have 2 dva over dt plus 2 dvb over dt plus dvc over dt equal to 0. So we know that dva with respect to time is our acceleration. So this will now be simplified again to 2 times acceleration a plus 2 times acceleration b plus a of c, and that's equal to 0. So to further understand the dependent motion and relative motion, let us solve an example. So let's say two automobiles, A and B, are approaching each other in an adjacent highway lane, and at time t equal to 0, A and B are 3,200 feet apart. So their speeds are recorded for VA at 65 miles per hour, and for VB, it's 40 miles per hour. And they are respectively at points P and Q. So knowing that A passes a point Q 40 seconds after B was there, and that B passes point P 42 seconds after A was there. Determine now the uniform accelerations of A and B, and the time when the vehicles pass each other, and lastly, the speed of B at that time. So we have here a simple diagram of our scenario. So we have here vehicle A moving at 65 miles per hour at point P. So after 40 seconds, it will now be at point Q. And then for vehicle B, it started at point Q, moving at 40 miles per hour, and at 42 seconds, it is now found at point P. And we have the distance between P and Q here. So for our solution, for the first part, what we will do is to first identify or convert our speeds or velocities in feet per seconds for more convenient computations. So for VA, we now have 95.33 FPS or foot per seconds, and our speed or initial speed for vehicle B is at 58.667 feet per second. So for letter A, we are now required to solve for acceleration of A and the acceleration of B. Then for our second question, the time that they will pass at a certain point. So meaning kung saan sila nag-meet. And then C is the speed or velocity of vehicle B at the time na they meet or pass each other between P and Q. Okay, so since we have converted already the values of our speed into foot per seconds, we can now solve for our accelerations for automobile A and automobile B. So let's start off first with automobile A. So for automobile A, we can now set that at point P, its time is 0 and its position x sub O is also 0. And we will set now that the positive direction is to the right side. And with that, we can now use our equation for position. We now have x is equal to x sub O plus VO sub t times V sub O times t plus 1/2 AT squared. So, meaning, for A, this is x sub O, this is x sub O is 0, final position is 3,200. So, for 95, this is our VO. And the total time to travel from point P to point Q is now equal to 40 seconds. So with that, we'll now have 3,200 is equal to 0 plus 95.33 times 40 plus 1 half A times 40 raised to 2. So computing now the value of the acceleration of A will now arrive at negative 0.767 feet per second squared. So what does this mean? Our acceleration now for A means it is moving to our negative direction, or it means that it is decelerating. Okay? So next, we move to the next one. We have for automobile B. So for automobile B, at point Q, so at point Q, this will now be its starting point. So this will become its x sub O, which is 0. And its final position is at P, which is 3,200. Okay? And then we'll assume that the positive direction is to the left. So therefore, your VB sub O will be a positive value. So in that case, we will use again the equation x is equal to x sub O plus V sub O t plus 1 half AT squared. So substituting our value, that will now be 3,200 is equal to 0 plus 58.667 times 42 plus 1 half AB times 42 squared, as it would take 42 seconds to travel from Q to P. And in that case, A sub B now is equal to positive 0.843 feet per second squared. So positive here means it is moving in our positive direction, which is to the left. Okay? So, question, ma'am, why did we use a positive direction to the left? Isn't it that our positive direction is to the right? Bakit naging positive yung left? So, this is just an assumption. Okay? So, if you want to solve it with to the right as positive, then we can do it also. So, if we will now have to the right is positive, so in that case, our V sub B now will be a negative value as it is opposite to our positive direction. And likewise, the initial position now will be, so this is 3,200 and this is 0. Okay? So this will become our x sub O and this will be our final position for this. So the positions, the numbers will be based on the position of A. So with that, substituting now using the same equation, x is 0 equal to x sub O, 3,200. So plus negative 58.667 times 42. So let's assume that the acceleration is positive, meaning acceleration is moving to the right. So I will have 1 half A of B times the time of travel from point Q to P is 42 seconds squared. So if we're going to compute, I will now arrive at acceleration of B as negative 0.843 feet per second squared. So as you can see, we have the same magnitude, but we have different conventions. So in this solution, the negative sign here would simply mean that the acceleration is moving in the negative direction, which is to the left. Okay? So same lang siya. Left to the left si 0.843 dito, to the left din siya. Okay? So that's for the first question, acceleration of A and B. So for our next required, we want to solve for the time that vehicle A and vehicle B would pass each other. So meaning, we want to solve this point wherein they will meet. Okay, so we have this point. So let's call this point G, for example. So point G will be defined by the distance of XA and XB, which is the distance traveled by vehicle A from point P to G, and XB, which is the distance traveled by vehicle B from point Q to G. Okay? So, with that, we can now solve further time by the use of, or equating now, XA plus XB is equal to 3,200. And from here, we can also derive that XA is equal to 95.33 plus 1/2 times the computed A times the time it will reach point G, or the meeting point. Okay? So this will be our equation 1. And using the same equation, we also have x sub b is equal to 58.667 times the same time that P reaches point G plus 1/2 times 0.834 T squared. So we have T here for A and T for B is the same. So if you want in your solution, you can write also TA here, TA, this is TB, this is TB. But you have to take note that TA is equal to TB since it's the same time that they will be at the same point. Okay? So with that, we can now substitute A and B in our first equation here. So this is equation 2. So we now have equation 1 plus equation 2 is equal to 3,200. So with that, we'll now arrive at a quadratic equation. So we can solve now for the time by quadratic formula. And that will give us now a value of 20.86 seconds. So for our next required, we want to solve for the speed of V, or of vehicle or automobile B. So in here, we'll now use the equation V is equal to V sub O plus AT. So we know already your VO. We have solved in A, your acceleration. And we have solved the time to reach or to meet. So, ang unknown lang is your final speed at time t. So, substituting now the values, will now get 58.667 plus 0.34 times 20.686. And we will now arrive at the speed or velocity of automobile B when they meet or pass each other at point G is 75.919 feet per second. So, the solution, if we want to solve for the speed of A, will most likely be the same also. So, dito, if we want for V sub A, that will simply be V sub O of A plus the acceleration of A times the time that they will be at point G or they pass each other. Okay? So that's for our uniform rectilinear motion and the relative motions. Thank you for listening. So if you want more examples, there are more examples on your modules. You can read them. So if you have any questions, clarifications, feel free to comment them on our classroom. So for your evaluate activity, please answer the elaborate questions found in Module 1, Unit 2 of the posted module in the classroom. Please submit a PDF file of your complete solution.